My name is András, and I'm the VP of Data Analytics at Innovate, and today we are going to talk about how you can get business logic out of legacy systems and how you can use reverse engineering to get logic out. So Innovate is a consulting company, and we do projects for a lot of large companies. And what we are seeing is that many of these companies go through a scale-up phase. Either their whole company or their data teams. It's not uncommon that their data team grows from 10, a headcount of 10 up to, let's say, 150 people. And what happens during this time is that at the scale-up phase, these companies have to deliver with results. That's the reason they stay alive on the market, and that's the reason they can grow. And usually, they are already of simple problems and simple solutions. So within the scale-up phase, they solve their simple problems that are generic for every company. And at this size, they focus on more specific problems to their products, to their industry, or specifically to them. But they also have to create specific solutions. And we have to also mention that analytics is always secondary to most companies, in the sense that we have a couple software engineers here. Stuff is always more important than the data and the tracking it generates. So what these companies end up is a lot of undocumented legacy solutions the space. So I'm going to just to show you how this works, and so you can feel that you are data analyst at such a company. Let's say that you get request from someone in finance, and they are in that what's going to be our flow for the next. We have our invoices table where we can see that what invoices are going to be paid next month. And we also have a different type of invoices. There are some draft out, so we don't want to count. Probably a SQL, adding together the invoice amount, filtering it, grouping, and to make it easier, you have a data lakehouse, which essentially means that you have a clean data set, and you are going to write a SQL query. So to do that, I to look into your invoices table, and the reality is that you realize that there are two invoice statuses. There is one invoice status Stripe, has the actual value, let's say draft or sent. You also have an invoice status that's actually an integer from 0 to 4, and you have no clue what that means. These two columns are not matching, so that you get completely different invoice status compared to the Stripe status. So your task is no longer to write a SQL query. Your task is to figure out who the hell created this data, how the transformation logic look like, which system does those two columns come from. So this is very typical at larger companies. We understand why this happens. First is that you have solutions that live long. So I've seen solutions being solutions specifically reporting that been alive for decades. For example, I once touched the code recently that was initially written in the early years of 2000. So you actually get 25 years of code. That code was probably worked on by at least 24, which is relatively a high amount in SQL and in data. And so the code was written by multiple departments, as the teams are large. They are completely siloed, so there isn't one single person who understands end-to-end to the end. Also, it's very common that the person who initially created it, or at least who touched it the last time, has left the company 3 years ago. And the only reason you own this solution is because there was a reorganization, and somehow you are the last person who's supposed to be on. And you would think that these solutions are not important, that they're not good in terms of quality or in terms of impact. But the reason, because they have been worked on for 20 years, that often means that they are already built or baked into the company's function itself. So as a result, if you break it, then it's possible that the board won't see the sales numbers from yesterday or last week. To give you one example, we've been working with a client, and there had been a data pipeline Sabi explained that presentation, there has been a data pipeline that went through multiple teams. So by the end, one metric was actually making it into the shareholder reports. So as they close their financials, shareholders were seeing this metric. And then we realized as we were migrating this code to a new platform that is completely broken. It was referencing a system that no longer had that data, so it was less using dummy data to certain points. And then the biggest problem is that these things are not even easy to fix, because suddenly your shareholder report is going to change, and then essentially the CEO has to explain it on the next shareholder meeting. So as I mentioned, we as a consulting team usually step into these companies when there is some larger work to be done. One specific example would be migration or platform migration, similar use case what Sabi has explained to you in his presentation. And is that we can just use agents to extract some properties of this code. For example, we've done a relatively large solution, meaning that it had about 40,000 line of SQL code, which in regular like product code, 40,000 shouldn't be too much, but in SQL you can embed a huge amount of business logic in there. So I'm going to drive you to that, what we have used simple tricks to get of that code. We could easily navigate and then understand it better. So first thing that we're trying to get out of it is data lineage. I'm going to explain what data lineage is, but you can get it on table level or column level. Here it's mentioned as description level. I'm going to show you how it works. And you essentially want to get out that the transformations, what they do, how they work, what calculations do, and also if they handle any edge cases. So this is a data lineage. This is essentially a pipeline. The idea is that you have data created in systems. So maybe your customer's data is created in your product. Your subscriptions are handled in Stripe. Then they are constantly being transferred through multiple layers. And then you get at the end to the actual consumption, which might be simple reporting, might be integration to other systems, or it can be even feeding class. So this is, of course, nice once you have it drawn out. There are even tools like DBT where you can write references and it can easily generate it. But for legacy code, you don't have that. There you have either store procedures or create table as select. So you don't have that luxury. So for this use case, you can write really simple prompts, and whether you can do it through the built-in chat, you can do it through an API, or you can use IDs as well. But this is not too complex task. You can actually get it out. The fun fact is that you can do this without AI models. If you actually parse the SQL and you are using a SQL model library, you could get it done even without that. It's relatively simple, and you are going to get that what columns are, what tables are being used by that model. So you would actually get the two tables that are directly related to that model. Now, this is all nice, but you still don't know that what data is coming from, let's say, customers and subscriptions, so that you could build your model. So you can some data lineage and data governance tools give you column level lineage. In our case, we don't need a full column. We just need a description of what group of columns are being used. So it would give us that from customers, we are only using the company size, and we are essentially using the subscriptions, such as the status, billing period, timestamp, and the revenue itself. So at this point, you already know that which tables are being used and what data is used for each table, but you are still not familiar with the model, the transformation itself. You can prompt that, and basically you get a description, essentially get the documentation, the written documentation of that table. So you prompt it. You can prompt it in such a way, and essentially what you get is your business logic. So here, this was a relatively easy use case. It was about a 60-line SQL, and what it did, it transformed subscription table that had subscription lines in it into subscription changes that tell you if a plan is opened or if a plan is closed. it can find these type of business logics relatively well. Well, we also have the calculations of the metrics that are used in that table, and we also have the edge cases. So there was one specific filtering where it had some help that there was a command that we are filtering out an internal organization that's used for testing Stripe. And actually, the second one is less relevant, but it actually code that in case there is delay, this ETL will still work well. Right. So the nice thing about this is that if you have a relative, so this was 60 lines of code. It wasn't even complex. Get basic how models are working. Even if you run it on larger code bases, you can get similar results. There, you probably want to push additional context in there. So what we have also done is that we had any kind of documentation that pushed in there, and also as you left to right, so you would actually figure out what customers is, what this table is, how it's being used in the dim customers table. Then you would push the definition of this table further. And what we have realized is that it can get the lineage relatively well, and it can get typical business logic out of these models. So if it's easy to understand, then you're going to get the right results. Otherwise, you always need human review to figure out if what it generated is right or wrong. And the reason for that is that agents cannot read minds. This is no surprise, and Sabi talked about this as well. So the biggest problem still is that organizational knowledge is low in people's mind. So they solutions work and they never write it down. So you cannot really pass written information to your models. So it's really a question that where we can, as an industry, go from here. Maybe we will have models who are to ping other people on Slack and asking them, do you know how this transformation would work, or how this business process works? Also, what we've been kind of discovering is that we don't have the documentation for the source systems. So essentially, we are stepping one layer into the same problem that we don't know our transformation, even if we know them. It's also very common that the system has a documentation, but for some reason we are using workarounds on it, and it's not how we are using the system, not as it's intended. And then we also had cases where we just couldn't figure out why our data, our source data is strange, and then we realized that it has actually been edited by humans, and they haven't been following the same procedure, so we got some really strange data in there. Beyond understanding the code, you can do additional things with it. What we've done, so many cases we did great SQL to DBT code. Here with DBT, it's essentially a code that's later transformed into SQL. It's a complete framework that through built-in functionality and macros can the right SQL for transformation logic. You can also generate the documentation for it. Usually it exists as YML files. And once you have the definition, of the and the columns in there, you can use it to automatically generate your YML documentation file. And then very similar to what these are usually simple tests. So if you know that, for example, a given column is a birth date, then you know that none of your customers should be born in 18th century. You can similar tests on the code. For more complex testing or complex tests, you probably want to use dedicated tools and models, because there you can also use agents to generate it. Right. So on this presentation, we went through that what large companies are facing right now, how the growth phase is generating a lot of technical debt. And we've shown that data analysts are not really writing code. This is the tiniest part of the daily life. They are essentially figuring out how the real works. and what data is being generated from the real world. Large language models agents can help us to figure out existing solutions work. They can do it extremely fast, but they unfortunately cannot do it at the same level as a senior data analyst. And the reason for that is that there is need for communication, and there is also need for understanding complex business logics. So to could go with speed, but keeping the same quality. What we can do is introducing human in the or constantly fixing it. Thank you. So this was digital archaeology, and if you have any questions, then I'm happy to answer them.